So 12.1 was generally about sequences and how you get them, different kinds of sequences. 12.2 is about arithmetic sequence, and then 12.3 is about geometric sequence. I'm going to throw you both of those today. They're not hard to pick out, and they're the ones that you see most often. And then Wednesday we'll be talking about a different kind of sequence that you can use in something else, which is pretty cool, and then we'll finish up the chapter on Wednesday. Okay, so an arithmetic sequence is the sequence in which you add the same number to each preceding term. Most of you will look for that term when you're looking for patterns anyway. Okay, the number that you are adding, that common number, is called the common difference. Okay, and remember that number can be negative, so you really can subtract it as well as add it. All right, so this should kind of look familiar depending on thinking about what Melanie brought up today. We got A1, 2, 3, 4, same. Okay. And then here's how they work. A1 is first one, and then we take and add a D, that's A2, okay? Here's A1, we took another, added another D, that's A3, so that's A1 plus 2D, right? That one I don't need to rewrite, because it would be the same thing. So we got A1, A2, A3, okay, here's A2, 3, sorry. And we added another D, so how many D's do I have now? I have 1, 2, 3, okay? So again, there's a pattern there. The number of term tells you what's the number of D's that we have. It is actually what's the 1 minus, right? So 5 minus 1 would be that. So AN is, in terms of a formula, A1 plus N minus 1 times D. I'm going to write that smaller so I can write it in one spot here. AN equals A1 plus N minus 1 times D. Okay? This is the formula for AN. I'm sure it's going to show up. This would be helpful to remember, but it's how it works. It's not really that ingenious, okay? Because if you look, we have 1 less than the number of terms of the D's, because that's how that works. All right, so first of all, we're going to be able to pick out, is it an arithmetic sequence or is it not? Okay, it's very easy. I can say, all right, 7 minus 5 is 2, so I'm adding 2, I'm adding 2, I'm adding 2, I'm adding 2. Clearly, I'm adding 2, so yes, it's an arithmetic sequence. If we had to pick out D, what would D be? 2. If we had to pick out A1, what would A1 be? 5. A50, we could find, knowing the pattern. Okay, we're not going to, but we could if we wanted to. Okay, so if you take negative 4 minus 1, what's my, no, yes. What's my common difference here? Negative 5. Okay, 1 minus 5 is negative 4. Negative 4 minus 5 is not negative 7. So, it's not an arithmetic sequence. The first time I looked at this, I was fooled. I was like, yeah, 1 minus 3, minus 3, minus 3, but this is not minus 3. Okay, that's minus 5. All right. Okay, how about C? Yes, because 3 halves is really 1 1/2 plus a half. Gives you 2 plus another half gives you 2 1/2 plus another half gives you 3. So yes, and D equals that number that we are adding, which is in case is a positive. Okay. What about D? I think we've seen this one before. Is it an arithmetic? No, because we add. Oh, sorry. We add 3, and then we add 5, and we add 7. There's definitely a pattern here with even with the addition, but it is not an arithmetic sequence because we're not adding the same number every single term. That's the sequence, arithmetic sequence, is you have to add that same number. Add the same number, which is your D, to get the next term of the sequence. Okay? If it's a different number, even though it has a pattern, it's still not an arithmetic sequence. It may not even be a geometric sequence. We'll figure that out today. So that's the first piece, is figuring out, is it an arithmetic sequence? If it is, okay, so they're going to tell you it is sometimes. They're going to give you some information. A1 is 4 and D equals 5. Okay, A says to find the first 5 terms. All right. So part A, first term is 4. What's the second term, Elena? 9. Good. What's the third term, Rachel?
Wait, I'm catching up.
You're adding 5 each time.
Oh,
14. Okay. What's the fourth term, Bridget? 19. And number 5, Melanie, is 24. Okay, those are the first 5. We're adding a 5 to the preceding term to get the following term. Okay, part B, write AN as an equation. All right, we fill in what you know, but we start with AN equals A1 plus N minus 1 times D. Okay, so A1 is filled in, and D is filled in. All right, that's usually simplified. If you look at it like this, you can see what, you know, your A1 is and your D is. But let's simplify it, and then algebraically, what does it look like? 4 plus 5n minus 5, or finally AN equals what? 5n minus 1. Okay? So sometimes your formulas are finished like this, and you're like, well, that can't be 1 because it doesn't look like I'm adding. But once you start putting a 1 in and a 2 in for n, you'll see that, yes, you're in fact adding the same number. All right. Part C, 50th term. Here we go. A50. That's what we're looking for. All right. I can use 4 plus 50 minus 1 times 5, which makes sense. In my head, I start with the 4 and then I add 49 fives. Okay? 49 times 5, what is that? 245. So 245 plus 4 is 249. I could also do this one. 5 times 50 minus 1. 5 times 50 is 250. 250 is still, minus 1 is still 249. Just because of what you have. If you have that one, if they, you know, if you hadn't done that already, I wouldn't go there. I'd just plug in right here and find it. Okay? First, okay, any questions on that problem? Anyone? All right, so let's do the next one. Find the first term and the common difference of the arithmetic sequence whose 8th term is 4 and 18th term is 9, negative 96. Okay, so at the beginning we have a 1, 2, 3, 4, 5, 6, 7, 8. 8 is 4. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And the 18th term is negative 96. Now, can anybody tell me about D, what it might look like, without being too specific? Okay, but can you tell me what sign it's going to be? Negative, that's what I was looking for. Just FYI, D is negative. Okay, so Karina was wanting to tell us how to do this. This was at the beginning of your education about, that's like just laying it out there. Okay, now what do we want to do? You could use A18 is A8 plus how many D's? Okay, there's 7 D's because I'm going to add a D here. And I'm going to add one here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who said 8? Okay, it's okay. You don't have to click it, but sorry. Okay. Now, we know this is A18. We know that is negative 96. We know A8 is 4. We have everything but D. Okay? So basically, to do this, I just used how many D's. I just kind of used the principle of arithmetic sequence. I didn't really go back to a formula. Okay? So I subtract my 4. I got a negative 100. And D is, in fact, negative what? 10. All right. So once we have D, we are looking for a formula for the nth term, okay, which requires D. So let's see. A n equals A1 plus n minus 1 times negative 10. Okay, D goes right there. All right, now we got to find this thing, and we're good. The n will stay. Okay, so D, A1, how do we get A1, which is way back here? Okay, so since we're dealing with A1, we can actually go back and use the formula, can't we? A8, and 8, in fact, here becomes 8 minus 1, which is 7. Okay, A8 is 4. So you can use that formula, or yeah, you can go back and say, okay, I got D here, 1, 2, 3, 4, 5, 6, 7. That's where the formula came from. So it just depends on what kind of thinker you are. Are you a very algebra formula person? Then you'd go back to this formula. Otherwise, some of us would just add the D's and figure it out. We know the concept, we can figure out. All right, so A1 is going to be the only thing missing here. What's A1 going to be? 74. Okay. So 74 goes there. Put 74 right there. Now, if you really wanted to check your stuff out, you can start subtracting D's. Just to check, 74 minus 10, 64, 54, 44, 34, 24, 14, 4. And they keep going if you really want to check. Okay? All right. Any questions on that problem before we kind of wrap up? All right. There are 2 ways to identify the rule for the arithmetic sequence. Write as AN in terms of A1, D, and N, which is this one. AN equals A1 plus, what's the rest of it? N minus 1 times D. Okay? All right, for the recursive is, like we talked about last class, is defining it in terms of the preceding terms. So, in this case, AN for recursive is something about A n minus 1. What would be this one? Where is it? I decoded this formula. What's the recursive formula? I just added a D to the problem, is what I'm saying. Plus 5. Right, because that's how you get the next one. So this is, again, I'm here. A n equals a n minus 1. How could we do this generically? Plus d, right. So that's basically the whole way we defined arithmetic sequence from the first place, in the first place. Okay? So we got two ways. Recursively is with the n minus 1, and then the other one is with the a1, the n, and the d. All right. Okay, so we have a sum now of an arithmetic sequence. Okay? Before we were just talking about the arithmetic sequence. Notice we're not adding this one and then this one and then this one and then this one. Okay, I know for a fact that quite often they ask us to find the sum of the first odd integers on those ACT tests. Okay, they don't really expect you to add in your calculator 1 plus 3 plus 5 plus 7 plus 9 plus, and then you wait, how am I going to know when I'm done? And I got to count 1, 3, 5, 7, 9, 11, 13. Okay, you'd be like, I can't. Okay, so this is what this is for, this theorem. Okay, this is to find the sum of the first n terms of an arithmetic sequence. This is the only time it works if it's an arithmetic sequence. Okay, Sn is, of course, the sum of the in terms. Okay, now check it out. This k equals 1 to n. Here's your formula for an, right, in terms of an arithmetic sequence. Okay, and then if we put that all, spread it all out, here's what we get, or we get this. Okay, I like to remember this, because this I already know. That's this. Okay? I know there's only so much I can remember. So I'm going to take 25 of those, or sorry, I'm going to go back down here. Find the sum of the first 50 odd integers. What's A1? First odd integer, 1. What's D? 2. Okay? So we are going to find the sum of first odd integers. We're not even going to be very formal about it. We're going to find n50, the first 50 integers. So we're going to do n over 2, a1 plus an. Now, sometimes you have an, sometimes you don't. In this case, we don't. So we're going to replace an with this formula. Okay? So I'm going to add a1. Wait, put my 50 goes here. A1 is 1. A1 is 1 again. N minus 1 is 49. And D we said was 2. Okay? 50 over 2 is what? 1 plus 1 plus, what's 49 times 2? 198. 2 plus 198 is? Sorry. 2 plus 98 is 100. 100 times 25 is? Okay. Now, we did it a little bit differently in geometry. We were going to look for a pattern, but this works as well. But the key is you got to remember that you take the front one, you take the last one, and you multiply by how many times it showed up divided by 2. Okay, I know it seems simple, but when you got all that other stuff going on in your head, it's not that simple. Okay, let's again find the sum of the first 50 terms. All right, you want to try it by yourself? Yes? Okay, I'll give you a minute to start and then I'll just start doing it up here. And hopefully I won't beat you because you're starting. Here. And you have your calculator when you take the ACT, so don't be worried about like, oh, I shouldn't have to use my calculator. You know, you can use it. I don't know why I was so weird about not using it here, but sorry. Right. 250 negative 236. Which 25 is that what y'all got? Can't multiply them. Okay. I'm trying to do tricky math, but it's not working for me. All right, let's try this again. Oh my gosh, I can literally just put that in the calculator. All right. 280 times 45 is grand total negative 7,000. What y'all got an hour ago? Okay. Now, did anybody check to make sure that was an arithmetic sequence before we used that formula? Okay, you did. Good, Amanda. Because, I mean, you'll figure out, that's in the process of right here. If you say, all right, this is 7 minus 6, that's minus 6, you get 2 of them, you're probably good. Okay, so that determines that, and then you know you can use this formula. Because you can't use the formula unless it's arithmetic sequence. The formula is going to be different. It's going to shape up different. Okay, now, this one right here, if you have your calculator, you have a summation thing on it, it should, you know, your best bet is just to throw that in there. And you're like, the only problem would be like, oh, I can't remember where it is. Okay, so first of all, you would have to say, all right, that n equals 1. Okay, n equals 1, what's a? 1. 3 minus 2, right? Okay, n equals 2. What is 3 minus 4? Negative 1. N equals 3. Let's do one more, because you don't know, 2 does not make a sequence, girls. All right, n equals 3. 3 minus 6. All right, is that a arithmetic sequence? Yes. Okay. D is negative 2. A 1 is 1. We are looking for how many terms? 90. Again, if this starts with 1 and ends with 90, you are going to count to 90. That's 90 things. So then you're going to say, all right, n over 2 times A1. Oopsie. Nope, not. That's D. A1 is 1. Now I'm going to figure out AN. I'm just going to do it in the context of this problem. So that's what, 89 D's, which is -2. Now I'm going to get my calculator out and do the rest. All right, what'd you get? -1? Okay. Now, if we did, now I just plugged in 45 parentheses 2 plus 89 times 82. You don't have to do everything all separate like you would if you were trying to mathematically, with your brain. Where is the... Oh, I got one right here. I'll just grab it. That way I don't have to remember where it is. I used E. This is going to change to, what is it, 3 minus 2n again? Delete, 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 delete. 3 alpha E.
3 minus 2.
Oops. Oops. 2 minus. Thank you.
3 minus 9.
Oh, for God's sakes. 2. Is that right? All right, and we're going to 90. Okay. 90. All right. Okay, it might have been easier to start. So where do we find it again? Down here at 0, right? So if you want to remember that, of course, that's another thing to remember. Math, 0, there it is. Okay? But if you don't, you just scroll and find it. Okay? Anybody now get 7920 on that problem? Now, if all you're doing is finding the summation of that, it is silly to do all this when you could just throw it in your calculator. You're going to be using your calculator anyway. But that's just to show you that that indeed is an arithmetic sequence. Okay? But again, that requires knowledge of this formula. Do something enough times. What does it say? 10 times it becomes a habit? I don't know. 30 days.
It's either 30 or 20.
Miss Cook says it's 10 times. To what? Did you say she's a liar? No, she's just a lot smarter than the rest of us. That's all. So, okay. So these, you don't have these. All right. Before we move on to geometric sequence, basically, you've got 2 things to remember on arithmetic. That's how you describe it. The geometric, this down here, one of these 2. And honestly, there's one in the same. It's just depending on how you want to describe them. And then that one. You can remember that one, but to me, you usually don't have the last term. If you have the last term, you just figure it out, and that's how that one is made up. Okay, so let's go to 12.3. I don't think 12.3 is open, so just short and sweet because we're not doing the last 2 pages. We're just doing the first 2 pages. Then we'll come back and grab some practice if we can. All right, so you all have this. Okay. So we're going to do the first 2 pages, and then the last 2 pages will be this Wednesday where we'll finish up the chapter. So it's just a little thing I want to show you on 12.5. Okay? All right. Geometric sequence is a sequence in which each term is found by multiplying a certain number by the preceding term. Okay? The number is called the common ratio. You can't call it a common difference. A difference is the answer to a subtraction problem. A ratio is a fraction. So say A1, A2, A3, A4. All right, let's check this out. All right, A1 is A1. Okay, A2 is is A1 times R. Okay, A3 is taking A2 and times it by another R. A4 is taking A3 and multiplying it by another R. You see the pattern of the number of R's and the number of terms. Okay, so what does A(n) look like? Claire? What's my formula for A(n)? If you still saw the pattern. A1 times what? Okay, how do you say R times R? R squared, and this is R cubed. So AR squared is A3. A4 is AR to the third. Does that help?
Yeah.
Okay, there you go. Very good. There's your formula. It's an exponent as opposed to a factor. That's how it works. Okay. Again, the next piece is to figuring out geometric. Is it geometric? Okay, so we have to multiply 1 times what to get 2? Times 2 again, times 2 again, times 2 again. Yes, this is R, in this case, is 2. Okay? The reason they call it a common ratio is because we find R by taking, say, A5 over A4. A5. 1, 2, 3, 4, 5, 16. A4 is 8. There's your 2. Okay? R is technically found by taking AN over AN minus 1. The ratio of AN to the preceding. Okay, but that's why they call it R. That's not big. Okay, what about this one? -1 times what equals 1? Times -1 equals -1 times -1. So yes, what's my R? -1. Okay? You're going to have a lot more decimals and fractions. You need to be able to kind of, if you think of this as 5/10ths, and this is 5/100ths. I know that's the same thing in decimal form, but it seems like it's more obvious. Do you see the ratio? 1/10, right. So if you're having trouble, you're just going to say, and I usually don't do the first, I don't know why, I usually go in the middle, but if you take 0.005 over 0.05, okay, we move the decimal, we get 5 over 50, simplify, we get 1/10. You got to do that more than once to check that it's a geometric sequence, but once you have a number to work with, you can kind of say, oh yeah, that's 1/10 and that. Okay, what about 4, then 1/2, then 1/8, then 1/16? No? Because what do I have to take? 1/2 over 4 is what? 1/8. And then 1/2 times 1/8 is not 1/8, is it? Okay. So not geometric sequence. So when I put a question like this on the test, I will say, here's a sequence. Tell me if it's a geometric, arithmetic, or neither. Because you have obviously some weird sequences that don't fit either pattern. Okay? All right, so recursively is A sub n equals what? I think that's one Claire gave us. No. No, it's not. The one Claire gave us is this one. AN equals A1 R to the n minus 1. Okay, who can give me the recursive one? Lydia?
R times just times.
Oh.
Right, because you multiply.
Oh, got it.
Thing, but the term that comes before it.
You mean A sub n minus 1?
Yeah,
Okay.
yeah, that's it.
A sub n minus 1 times R. Yes. Very good. Okay. That's that preceding term of A sub n. Okay? All right, so we also have a sequence. We also have some, we've got a sequence, find the 20th term. You can assume it's a geometric sequence, or you can figure out, oh, well, let's see. This is 9, this is 81, but really, what are we multiplying 3 squared by to get 3 to the 4th? 3 squared. So that times 3 squared, so R equals 3 squared. Okay? So you don't always have to go back to the original form. All right, so part A of that sequence. How would we find the 20th term? As in A sub 20. All right. Let's see. Amanda. You're using this formula right here.
As they do 9 times 9.
To the
20, 19.
Okay. All right. We do not need to know what that giant number is. Once it's past 6, we're kind of over it. So what is that? 9 to what power? 20th. Done. Okay. And it's only, you only combine these because they're both 9s. If it was 3 and then 2 to the 5th, you don't get to multiply this and get 6 to the 5th. Okay? The only reason we combine those is because they have the same base. Be careful about that. All right, good job, Amanda. All right, let's go back to the screen here. Okay, here's the sum of it. So you're going to do the same things with geometric sequences as you are with arithmetic sequence. Oh, shoot, we didn't finish. Okay. Define A recursively. All right. Recursively, what does that look like, Lindsay? A-N equals A1
3 squared times 1, which is 3 squared times, or to the 19.
Just generically.
Oh, then minus 1. Or in minus 1.
Okay. Now, simplify that. Very careful. Everybody simplify it. Give them a minute. Be careful. Here. All right. What does that simplify to be, Lindsay?
3 to the 4th times in the 4.
Okay, tell me what this simplifies to be. You get the power of a power. 6 squared to the 3rd. What's that? Okay, so do the same thing with those two as you did with the 2 and the 3.
So then the 2 and
All right. Now what?
so
3 to what power?
2 and
2 and good job. Okay, that's how you do it. That's your recursive formula. And again, it's probably more simplified than many of them are going to be just because we have the same number for A1 as for R. A lot of times we will not combine much. And then explicitly, we would do, I'm running out of room here, AN equals A1 times R to the n minus 1. Wait, So that was, okay, so this was C, wasn't it? All right, let's try B. B is a lot easier, I think. B is AN minus 1 times R, right? And all we do is fill in R. We'll just do a 9. Okay, is there anything else we can do? Not if we're going to keep the N. We got to keep the N. For recursive. Recursive is just using the AN sub N minus 1 and A sub N. That's right, right? Yeah, so we'll multiply by 9. Okay. So we're going to do the same things we did with arithmetic sequences. You did in 12.2 with the geometric sequence in 12.3. Yes. This says A sub N minus 1 times 9, and then I just put the 9 in front. Yeah, that's what I did. Okay. Another formula for geometric sequence, and this is a sum. Add them all together. Okay? So call it S sub N, just like I did before. You're talking A1 plus A1 times R times A1 plus A1 times R squared, yada, 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 equals this. Okay? It's very random, seemingly, but it works. Okay. So let's try the formula. Some of the first 5 terms. All right. Yeah. A1. I want y'all to be ready to be surgeons. All right. This is what we're doing. First 5 terms of 1/2 to the n. So this plus this plus, hello, this plus this plus this. Okay, go ahead and throw that in your calculator right now, because you can do it that way. All right. Or you can use the formula. I'll do that. Yes? No, it's written badly, but it's 1/2 to the n. Yeah, it's written badly. You're right. It's not written correctly. But that was the intent. Thank you. Always count on Miss Karina to be good with the details, right, Karina? That's a compliment. Let's see. Getting old. No, not really. Thank you for pretending.
It's trying to be quiet. You're mockery. That's my job.
All right, is that what you got?
Oh,
Yeah. Okay. Now, this would be quite a different story in the blue if you had like 50 to find, right? If you had 5, you might have probably finished way before I did, because I had to figure out the A1 from the formula, which is not that hard to figure out. Okay, then I had to figure out the R, which is like, okay, what am I taking times this to get 2 of them? Well, duh. I can see it, so that's my R is 1/2 again. And then I have 5 things that I need to find, so that's my N. So I plugged everything in here and have it there in the green. okay? Like I said, it would be a different story if you were looking for 50 terms, because you'd be like, okay, this problem, you know, when you're on the ACT and you're in a time crunch, you're not going to have time to plug in all that. You have to figure out the.
I think I might give you that one. I don't know. I'll think. That geometry someplace because it's kind of just random to do. All right. I think we're done for today. Okay. This we'll talk about Wednesday. So Wednesday. What kind of time we got? 5 minutes? You all feel like doing some practice?